energy. Scientists define energy as the capacity to do work. And work has sort of a strange definition. It's defined as the action of a force through a distance. So if you push a box across the floor, you did work. Did I get paid for it? No. Well, it was still work by the scientific definition. You pedal your bike, you've done work. You walk, you've done work. You go up the stairs, you've done work. You pick up your pencil, it's work. You're applying a force across a distance. And energy is the capacity to do something like that. There are different kinds of energy. We classify all kinds of stuff. We classify energy. Kinetic energy and potential energy are two big divisions that are important for us in chemistry. Kinetic energy is energy associated with the motion of an object. So here we have a 10 kilogram weight being dropped off this building. And the kinetic energy is when it's moving. Potential energy is energy associated with the position or the composition of the object. So the weight up here has high potential energy. It's not very stable. Things that are high energy are not very stable. Because you give that guy a nudge and he's going to fall off, right? As he falls, his potential energy decreases, his kinetic energy increases. Because his kinetic energy has to do with the speed at which he's moving. His potential energy has to do with how high above the ground. He's highest up here, and as he goes down, he gets lower and lower and lower. And so here is lower potential energy. This is more stable than up there. It's hard to fall off the ground, isn't it? You can fall off a chair, but when you're just, standing on the floor here, hard to fall off the floor. You're more stable, you're lower energy there. Where does all that energy go when it hits the ground? It goes into the ground as heat. Now, if you've got something of significant size with a lot of kinetic energy hitting something else, you can actually feel or measure the heat from that. But a lot of times this heat, it dissipates and we don't even notice it. But the energy does go somewhere. Then there's thermal energy. Thermal energy is associated with the temperature of an object. It's actually a kind of kinetic energy, because kinetic energy is energy of motion. Are the particles in a substance completely still? No, they're moving. And the warmer it gets, the faster they move. And so if we were to raise the temperature of the solid students, you would be getting more and more agitated, and you'd be fidgeting, and you'd be moving more. That's the thermal energy. It's a kinetic energy because it is movement, but it's not movement where you're actually going somewhere. It's just a kind of a fidgety movement. So the law of conservation of energy states that energy is neither created nor destroyed. Does that sound like another law that we talked about tonight? The law of conservation of matter, or the conservation of mass. Mass cannot be created or destroyed. Energy can't be created or destroyed. You can change it from one form to another. You can change potential energy into kinetic energy and then into thermal energy. Energy can flow from one object to another. If you put an ice pack on your arm, there's energy from your arm that's going into the ice pack as the temperature equalizes. But the total quantity of the universe is constant. You cannot create energy. You can only change it into one form or another. Objects with high potential energy tend to be unstable. Gasoline has high potential energy. It's not an energy of position, it's an energy of composition. Is gasoline stable? If you light a match, if there's a spark, kaboom, right? That's why you need to be careful when you fill up at the gas station. You definitely don't want to smoke or something or have static electricity. Bad things happen. Chemical potential energy comes from electrostatic forces between the charged particles that make up atoms and molecules. And we'll go more into that later, but it has to do with the chemical bonds that hold the molecules together. So energy is always conserved. You can't destroy it or create it in a chemical change. That's outside of nuclear. And systems with high potential energy tend to change in a way that lowers their potential energy and releases energy into the surroundings. What happens is energy tends to go from a more useful form into a less useful form. And so when you burn gasoline in your car, the gasoline has a high potential energy, and you burn it, and you convert some of that into forward motion of your car, kinetic energy, but a lot of the energy is dissipated into heat. And if you measure the amount that's dissipated in heat and the kinetic energy, that's going to equal the potential energy. But the heat that got dissipated wasn't a useful form of energy. And so when they talk about energy efficiency, they're talking about how much of your initial energy are you actually converting into something useful as opposed to stuff that just gets wasted.